Welcome back to day 47 of online learning. Today we're going over Unit 8, Lesson 2.3, and we're going to be focusing on solving division story problems. What I'm going to do now is I'm going to pull up our lesson goals and objectives for today's video. For today's video, we're focusing on being able to say, I will be able to divide a 2-digit number by a 1-digit number. I will be able to solve multiplication and division story problems, and I will be able to solve division story problems with remainders and figure out what to do with the leftovers. Before we dive into today's lesson, what I want us to do is go over problem number 4 on yesterday's have-to. So pull up problem number 4 on page 494, so that way we can go over your work. Is have number 4 on page 494 out, that way we're able to go over it together and think about the different ways that you can break apart this array. So I want you to think about what do you need to do first when you're figuring out the dimensions of an array. First, what you need to do is you need to figure out what is my length and my width. So I need to count the tiles and figure out that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 units is the length. And 1, 2, 3, 4 units is the width. The equation that I'm going to use to solve this array would be 4 times 27. And 4 times 27 is a difficult problem for me to solve. So I'm going to think about different ways that I can break apart this array into different multiplication problems that are easier for me to solve. So let's take a look at this first way that you could have used and broken up our array to solve 4 times 27. So you could have drawn a line straight down. Pause me and think about what would my equation be if I was to find the area of this part of my array. So if you did it this way, you broke apart the array and to have 20 units across and 7 units across. So you broke apart 27 into 20 and 7. Pause me and think about what my equation would be to show this part of my rectangle. So my array equation would be 20 times 4. I'm keeping 4 the same. I'm not breaking it up at all. And I know that 20 times 4, I can focus on just 2 and 4 since 20 is a multiple of 10. So that'd be 80 because now I'm going to have 2 times 4 is 8, and then I'm going to add my 0, so 80. What is my equation for this part of my array? This array would be 7 times 4. And I know that 7 times 4 is equal to 28. Pause me and think about what do I need to do now with these two areas of this array. So I first broke apart my array to do 20 times 4, and then I did 7 times 4. So I broke it apart into multiples of 10 because that's really easy for me to multiply with. And then I had 7 over here, but I kept 4 the same. So 20 times 4 was 80, and now I need to add 7 times 4, which is 28. So 80 plus 28, I see that there's 80 plus 20, which is 100. And then I have 8 ones. So I have 108 square units. I know that my units are the same for this array, so it's 27 units is the length and 4 units is the width. Pause me and think about how did they break apart this array to make it easier for them to solve. What they did is they broke it up with by 25 and 2. So my equation would be 25 times 4 over here. Pause me and figure out what 25 times 4 is. What might be nice for you to think about is that 25 is 1/4 of 100. So a way for me to think about this is 25 plus 25 I know is 50. So then 25 plus 25 plus 25 plus 25 would be 50 plus 50, or 100. 25 times 4 would be like having 4 quarters, which is equal to 100. And then my equation over here would be 2 times 4. And I know 2 times 4 is equal to 8. So now what I need to do is I need to add up my two arrays, and I get 25 times 4 plus 2 times 4, which is equal to 100 plus 8, or 108 square units. Pause me and think about, how did they break apart this array? This array is a little bit different. Instead of breaking it up into 2 parts, they now broke it up into 3 parts. What they did here is they broke this part up into 10. This is also 10 units across, and this is the rest of the 7 units. 1, 2, 3, 4, 5, 6, 7. So my equation here would be 10 times 4 is equal to 40. And then another 10 times 4. So all I'm doing is breaking up 27 into different equations that are easier for me to solve. So 10 times 4 again is 40. And then I have 7 times 4. And I know 7 times 4 is equal to 28. Pause me and think about, if I was to write this equation just like I did up here and here, what would it look like? So here all I did that was different is, instead of breaking it up into 2 different equations, I broke it up into 3 different equations. So I would just have to do 10 times 4 plus 10 times 4, and now I have plus 7 times 4, which would be 40 plus 40 plus 28, or 4 tens plus 4 tens plus 2 tens would be 10 tens, 8 ones, so 108 square units. When you break apart numbers in a multiplication problem, what do you need to pay attention to or keep track of? Pause me and think about, what am I trying to pay attention to and keep track of when I'm breaking apart my arrays or breaking up my multiplication sentences to make it easier for me to solve? I need to make sure that I'm multiplying all the parts and then add them together. I need to make sure that, just like in 27 units, I'm breaking apart 20 and 7, and I'm still keeping 4 units the same. As long as I'm having the same length or the same width throughout, it's going to have the same answer. I'm just breaking apart 27 into 2 different numbers that add up to equal 27, which make it easier for me to figure out. By using an array, it's really helpful to help you keep track of and get to know the right answers. So you could think about it as if you were to make a box, and think about if you were to break it up into different numbers that are easier for you to solve. So if you don't draw an array, you can visualize what this array looks like and how you could break it up into parts, or you could just make a quick sketch without drawing all the squares. So if I was to do this, all I have to do would be 27 units and 4 units, so I can make a box with 27 and 4 and break it up into my 20 times 4 and my 7 times 4. I'm breaking it up into my tens, or my multiple of tens, and my ones. But 4 is staying the same, so 20, so I'm breaking up my tens, and now my... For today's lesson, we're focusing on how to do division problems when these division problems have large numbers for us to divide with. So let's take a look at this problem. It says there are 78 third graders and the teachers put them in 6 equal teams. How many students are on each team? So what I want you to do is take notes of these problems showing number of groups, number in each group, and the total number. So take notes and separate the information into these 3 categories. So it says that there are 78 third graders, and I know that 78 is the biggest number I'm going to get. I'm not getting anything more. They're not adding to it. They're only going to have 78 students. That's my total number. And the teachers put them in 6 equal teams. So my number of groups would be 6 teams. And I noticed that they said that they're equal teams. And it says how many students are on each team. So we're trying to figure out in each team or each group, we're trying to figure out how many are in each. So what I want you to do right now is think about an equation that I can use to represent this. If I already know the total and I'm breaking it up into a certain number of groups, what is my equation going to be? So my equation is going to be 78 divided by 6, or 78 students divided into 6 equal groups or teams. And that's going to help me figure out how many are in each group. And I can also think about this in a different way. Pause me and think about a multiplication sentence that can be used to represent this problem. I can also think if there's 6 teams with how many in each will get me to 78. I want you to take the next couple of minutes and pause me and think about how can I solve 78 divided by 6, or 6 times what equals 78. Take your time and think about different ways that I can use these equations to help me solve it. When you're dealing these out though, what I want you to make sure you're not doing it. I don't want you to deal out one by one by one by one. Think about what can I deal out to make it go easier and also help me keep track of how many I'm dealing out. So if I was to use this division problem, I know that I have 78 students that I'm putting into 6 equal groups. 1, 2, 3, 4, 5, 6 equal groups. And what's so important is while you're doing this, to make sure that you're paying attention and really being careful, because it's really easy to lose track, especially with these large numbers like 78. What I'm going to do is I'm going to think of different ways to make it easier for me to deal out 78 without dealing it all out at once. So I know that I can do 6 times 10, which is 60, and 10 is an easy number for me to deal out. So what I can do is I'm going to just deal out 10, so 10, 20, 30, 40, 50, 60, and I don't want to keep going because I know if I keep going and counting by tens, I'm going to get more than 78. So now what I want you to do is pause me and think. I just did 6 times 10, so 10 6 times. Now what am I going to have to do to get to 78? I'm at 60. So I already did 10 times 6. Now I need to think about what else can I do. So if I already did 10 times 6 and now I'm at 60, I need to get from 60 to 78. And so 78 minus 60 is 18. And I'm going to think about what number can I break up by 6. 6 goes into 18 how many times? 6 goes into 18 3 times. So now I'm going to count by 3s, or I can even think about if I want to count by 2s. It's up to you. So I'm going to count by 3s because I know that 3 times 6 is 18, and I'm already at 60, so I need to get to 18. So 3, 6, 9, 12, 15, 18. So what I just did is I first did 10 6 times, and then I did 3 6 times. And 3 times 6 is 18. So 60 plus 18 is 78. And I also have 13 in each. So what I just did is I first dealt out 10 6 times and then 3 6 times. And I'm double checking to make sure that 10 times 6 is 60 and 3 times 6 is 18. So 60 plus 18 is 78, or the total number of students. I'm just double checking using a multiplication sentence to see if this still works. So I want us to think about what these numbers represent. In this equation, pause me and think about, what does 78 represent? $78 represents the total number of students. Pause me and think about what 6 represents in this equation. 6 represents the number of groups or the number of teams. What does 13 now represent? 13 represents the number in each group or the number of students on each team. I need to label it to say, what does 13 mean? 13 students on each team. So I thought about this in a way of division, where I'm dealing out 78 equally into each group. So I first dealt out 10 to get to 60, and then I needed 18 more to get to 78. So what you're going to be doing today for your have-to of pages 501 and 502, you're going to be working more with division problems, and some of these problems may have remainders, so you need to figure out, what are you going to do with the leftovers? If there's some that are left over, is it asking for equal groups? Is it asking for how many will you need to make sure everyone's included? Think about, what does my remainder mean? I also want you to be thinking about, instead of dealing out one by one by one, I want you to be dealing out in larger groups, just like we did with 78. If I dealt out each single student, it would have been really easy for me to lose track. Here is your have-to for today. It's pages 501 to 502, and it is division problems. So you're going to solve the problems and show your solutions, including what you decided to do if there's extras left over. So some of these problems might have remainders or leftovers. So it might not completely be equal in each group, so you need to think about how many are left over and what are you going to do with them. So make sure you show your work through 1 through 6. So I should be seeing your number of groups, or how you're breaking down your multiplication problem into numbers that are easier for you to multiply with. So make sure that you're showing your work and labeling your answer. Now let's take a look at your have-to slide for today. For today, you need to complete pages 501 to 502 division problems. You need to practice your FACSUM working on division flashcards for 10 minutes and do 15 minutes of IXL only on the highlighted skills. And your criteria for success is, I use strategies to solve division story problems and wrote equations that match the problem. I can solve division story problems with remainders by figuring out what to do with what is left over. And you can take a look at this rubric below to see how you'll be scored.